Alright guys, this is Aiton McFarland here with you with man versus math. Okay, I'm going to show you how to factor this good here equation. Alright, so first what we're going to do, we're going to take this 3x squared, take over to our negative 16, and that will give us a new equation of x squared plus 7x minus 18 equals 0. Okay, so next what we're going to factor, and to factor we're going to want two numbers that multiply into negative 18 but also add to 7. Those are going to be x minus 2 and x plus 9. Okay, so now we're going to want to take this 3 from our original equation, take over and divide. Okay, so because of this crazy x, that's going to go down into 2/3. This is going to become a negative 3 when we simplify. Alright, so this we're going to want to take up into this equation so we can solve that algebraically. So if you put this into a graph, you get, this is the graph that you get, and these two solutions, those are the points on your graph, on your x-intercept.
Hi, my name is Keyte, and welcome to Man versus Math. Today we will be solving this equation. Okay, so the problem is that a model rocket was shot from the top of a roof from the following functions right here. And the first problem is we're supposed to figure out how long the rocket was in the air. So the rocket was in the air for 7.623 seconds, and I got that from here, but since it's x, it's going to be crazy. So that's how long it was in the air, and I'll explain that here in a minute of why. Determine how tall the roof was. So the initial height was 15 feet, and I got that, and I'll explain that to you later too. How high did the rocket fly? It flew a total of 240 feet, including that. So you don't have to add that on later. Determine the velocity of the rocket, and it's going to be positive 16 feet per second, or how fast it's going. So it's going to be feet per second, because this is also in seconds and this is in feet. So that's going to be your velocity. So now to double check us, I plugged it into the calculator and graphed it, and that's what it looks like. Okay, so now let's start with the initial height. So if I go to table and then go to 0 right here, it's 15 feet. So this is right, and the reason why is because this equation goes velocity and then the height and then the initial height. And then for the total, if you go back to your graph, we can go to trace, and we can go all the way up to the very top. Now this isn't going to be exact, but it's going to be super close. Like, oh, sorry. Look how close that is. So we know that's really close to 240, which is the right answer. And then for your velocity, I have no idea, but it has all of them here, so that has to be velocity.